Hello, sir. Good evening.
Hey, Yanshika, how are you?
Good evening, sir.
Very good evening. Let me just give you the host. Yeah, now I think you are the host. So let me quickly share the mail to all the students. Just a minute. Yes, Yanshika. So I think I sent a notification to everyone. So probably what we'll do, we'll start with the auto were covered yesterday, and
Okay.
we'll just see like how each and every point were tracked and what all we will cover today, like what the past completed session as well as the agenda for the today's session, and then probably by the time members will join, and then probably we'll take it further.
Just let me know while messaging like when to start that or
No, we'll
what
start
will
now.
start.
We'll start now. By the time the people will join.
Okay, should I start now?
Yeah, yeah, please start.
Okay. I hope my voice is audible, sir.
Yes, Anshika, very well.
Hey everyone, welcome to today's session. I hope everyone is being safe and doing good with yourself. So, as read yesterday, we read about the introduction for the data types and covered the data types in Python. Before going to this session, that is the introduction to NumPy, I would like to recall the stuff we read yesterday about the data processing and how the data is being extracted. So data processing is just in like classified into the structured data and unstructured data. So moving forward to the structured and unstructured, both are being different to each other in the sequential parts, as we read yesterday. So while moving forward to the sequential as well as to the structural, I'll be suggesting you to read the data before shifting to reading NumPy or practicing NumPy, because knowing about the data is very very important before NumPy, because you might be knowing about what is the NumPy and how the data is being stored actually in it. Okay, so like directly moving to NumPy, that is also not good. Before that, you have to know what is data. Okay, we read about how we process data, what are the levels to process data, and how the data is being processed. So in structured data, we read about that it is the formatted and predefined data, which doesn't need any of the more processing, because it's already been processed by given as a raw data also. But moving forward to that, as we want to format this data, or we have to set this data, we always need some of the reference. Okay, while doing the reference, when you will be doing the reference part to the data, it is more often like your data is more prefined. Okay, like more prefined, your data will easily be processing further to get your output. Okay, moving forward to the like what are the pros and cons of structured data, and what are the pros and cons of unstructured data. So pros of structured data are very very similar and a very very simpler part to know about. So as I read yesterday about what the pros and the cons of the structured data is, it's completely a similar word, that is that it is easily used by the machine learning algorithm. The machine learning algorithm are very very beneficial by using the structured data, because that how we have a specific and organized nature of structured data. Okay, while moving to that, it is easier to get that the manipulation and querying of your data. Okay, now what is when you have proper easiest data form, what you can use, you can use in the machine learning algorithm, you can use in the business users, that is like when you are being using that data to like process to have a self-service relationship with the data, it will automatically give you an average business development in that. Okay, third point is it is increased access to more tools, because your data is structured. Okay, now you can have a far longer than the benefit from that, nothing else, but you can just shift to that. So cons for the data work, like moving forward to the what were the cons of structured data. So first, very very important, like we have to use as a limited part, we always stuck to the purpose of using the limit data, because while writing the code in the schema, or while writing the code in the SkyPy, it will be giving to you a much more like problematic, because either your data is being inputted and you need a proper output program, that is the refined data. Okay, now the data which is refined is already being used by you. What happens when you are being using the data in the schema, that data will be refined, but it will also require more of data in that. Okay, you have a data predefined for the writing the schema codes or any of the like SkyPies, but you have to get that more, it will asking you the more of the data, so that will be problematic to you. What data you will be refining that? Okay, so it always like it has a limit to use the data, and it is flexible, like you can use that cases, test cases for using limits of that. Okay, and third point for using the data is like it is the limit storage option, which means like if you are uh, if you have a box, okay, and you have only the capacity of that box is 5 kgs, okay, and not more than, when you will be putting more of, like, suppose you have put one more kg in that, it will not hold that, or it will not, like, it will either just get apart, or either it will not store it, because the limit of the data is only, limit of that box is only a 5 kgs, not more than the 5 kgs. That how every data has a storage limited. That means that every structured data has been sorted in the data house warehouses. Okay, now what is data warehouses? It is a place where the data is being stored, okay, with the rigid schemas. So rigid schema means, like, it has a proper portions to store the data with the structural and sequences part. Okay, fourth point is that it has a, some of the cost can be migrated. Okay, like, cost is highly expensive, so it cannot be used as the scalability. Okay, so it has a greater scalability, but it will eliminate your maintenance cost. Got my point? Now moving forward to what is the unstructured. For moving forward to unstructured, it is just vice versa of the structure. That is, like, in that we were processing the data with proper sequentials, but in this we are not used to data store the data in a native format. We can use in a structured data the formatting. Okay, in the unstructured we cannot use the native format. Okay, while moving forward, like, we can process in that proper, like, storage, but in this we cannot. The most of the examples where this unstructured data is being used, that is charts, presentation, like, it can be used in, like, includes, like, our emails, social media posts, and many more. Now what were the pros of the structured data? There are three pros of the structured data. Just remember that it has the freedom for native format, it is the faster than accumulation rates, and data leakage is much more not often in that. Okay, because it has a massive storage, and whatever it can be used for the proper usability scalability. Okay, and the more of the accumulation rate is, the more is the beneficial to you. Always the native format is just to adapt. Okay, adapt in the sense you have the greater variety of files format in your databases, or in your file managers, or everything, because that data is cannot be, like, stored uh, without the permission. Okay, it is always restricted to a specific format, and it needs your permission, like, whether this data is being formatted, not formatted, or what is the storage of that, memory allocations for that. Now moving forward, what are the cons of the unstructured data? So unstructured data requires, as also I told you yesterday, like, it has a two major points to remember always, what are not to be, like, forget this of the unstructured data, because it is most often used to that. If you are being not remembering the unstructured data, what are the unstructured data, it will be problematic to you, obviously. So in unstructured data, we requires the data very much expertise. Okay, expertise, like, the largest with the network we have, or largest the the data we have. Okay, more is the unstructured data will be preparing and analyzing by yourself. Okay, because in structured data it is not openly used in that. Okay, expertises are not used in the structure, but in the unstructured, that is oftenly used by the areas of the data. Okay, second is the specialization of the tools, what tools we are being using. So always use the tools that are being used to manipulate your data in your what the limited choices you have, and it is giving the proper output of it. Okay, always use that tools that are manipulations, that is manipulated and that are required for expertises. Now I told you yesterday about the what are the data processing cycle. There is a data processing cycle according to which it is a similar. that would be helping you out to get through each and data refining and the processing. So there is the stages of the data processing. First of all, we need input, then processing, then output, and storage, all the connection functions. Okay, remember one: input, processing, output, and storage. Okay, four things are there, and the four other stages are there. When your data, when you provide your raw data to a system or anything, it will process your data. Now, how it processes your data and what are the condition of processing the data, it always depends upon the what raw material you provided. After that, refining it will provide you the output, and giving the output, it will like now allocate you the storage memory storage, okay, for all the data to be stored in. So when your data begins with the input stage, it always and always, because in between, like if you are doing processing and your processing is complete, your data will not be like leaving in between of that. It will always be getting to the output stage. So what were the cycles to be known about the input, processing, and output? And output is the final information you get. Input is a raw data you provide, and processing is wherever it will be taking place of it. So input input data doesn't require any of the information, because output is the ultimate source of your information, and it is the final structure of that. Okay, now when it is like when your data is being fed by any of the data processing or any of it, always remember that it is a meaningful information, because processing means it is an meaningful information, it is not an unusable information. While when you get to your data processing or when you get to the system, uh, it has an input stages convincingly telling us what are the activities containing in our input stage. For input stage, we have following activities, that are 5 activities: data collection, data capturing, encoding, data transmission, and data communication. These all are the classification of input stage. We know the data processing cycle, that is input, processing, and output. Further, the classification of input stages: data collection, data capturing, encoding, data transmission, and data communication. Okay, now, what is data collection? So, collection means like we are gathering some of the information, data, or we are getting some of the data from our surroundings, we are from our environment, like we are being like surviving or anything. So, we are being getting that data from our surroundings. Okay, now that data, what it will be doing, like we need the data. Obviously, we will record that data and everything. That recording of data is known as source code. Whatever it has been collected, that data is known as the source code of that. Okay. Now, moving to the data capture. 5 activities were there. Data, that is data collection. Now, data capture. Now, data capture means all the data we collected, all the data is being collected by your environment or by your surroundings, that is all entering the collection of the data, and the data is being sent or data is being entered to your processing system, that is your obviously your computer system where your processing will be happening. So data transmission means sending something. Okay, now your raw data, that is input data, it will be sent to your processor, and after that your processor will take that data to various parts of your computer, or like processor or any of your components of that. Okay, now from your data is being gathered from the environment, data is being captured, data is being transmitted. Now it is being involving what the data, where the data has to be sent and how. Now for the processing stage, that we read about the activities of the input stage. Now the processing stage of our data is like always the raw data is being transformed to some of the meaningful information. Like suppose we have been learning alphabets or the ABCD in your nurseries. Is it gone like breathlessly for you? Is it meaning this that is meaningful to you? Because learning this basic of your alphabets A, B, C, D, E, F, or the alphabets to be read as. Now you're making a big statements of it, or the wordings of it. Okay, so that learning, that was a raw data. You're learning the raw data. Now you did the processing, make small words, or make that even the sentencing. Till now you're making a paragraphs of that. So it is being useful to you, and the processing has been done really useful to you. Because raw is always being meaningful, equals to the meaningful while doing the processing. So when the computer just follows the instruction called the program to process some of the data in the preprocessors or anything, it always used to get that information in a respective manner or in a respective sequence. Now what happened when we give to the like our data, we provided a raw data, now we processed our data. Now where did that data will be going to? So that data is going as an output stage. The data is processed. Now the processed data will be presented to us as an output devices. Okay, the when the output, we provide the output devices or anything, it is always been useful to us. Okay, when any of, suppose you are being um suppose you have like you attach the mouse to your laptop. Okay, or you did any of the external device to your laptop. While connecting to that, your like mouse, I have been clicking over here and there. Okay, now this is advice to my user, and I need, wherever I am clicking, I need the basic output. Okay, they then only I'll be understanding whether this device is working, whether the data I provided is working or not. That is what called the decoding part. Okay, so after when you provide the raw data, process your data, then you get the data to where to store the data now. So for that, we had a storage stage, that is a storage memory allocation, such as we use hard drives, pen drives, then memory cards are there to store an information. That is the storage stage of our raw data, and our processed data, that is an output data. So here's a very good processing cycle, data processing cycle, from where we collect the data from our surrounding. Then we get the input data, that is the raw data. Then we send to processors to like have a meaningful objections. Then the output we get as a final product. Then the memory allocations are being done so that we can use this data as in proper state. Okay. Now, what are the process data? Okay, what are the different forms of the process data? Now we read about what is the processing cycle. We read about what are the structural part of the process cycle. So moving forward, that we have a lot of forms of the data, that is sorted, then it is grouped, then it is furthermore calculations, and where the data has been formed. Okay, now what happens when we do the sort data? Sort means we are arranging that data, or we are organizing that data according to our predefined criteria. Okay, like suppose my predefined criteria for sorting data is ascending order, or like I want according to day or time. Okay, might be you people need that data as in descending order. Okay, as in like the size orders, like whose memory is being larger is to be shown first. Okay, that is the sorting. It is according to user demand, where the data has been organized with the structural part. Okay, now because it is obvious, right? When you like sort the data is obviously like showing to you that is an easiest part. Okay, when you like have an mobile phone numbers, that's an alphabetic order as an ascending or descending, wherever you're, it is easier for you to find out. Or the A section, you scroll up, like at the A, these person are there, then B, C, D. It is easier for you because that's how you've been learning towards. Okay, now it is group data. Now group data is pretty like structural part, because grouped means like we have a cluster. Okay, so cluster means like we have a one group data, one data, two data, or anything. We each of the data we are being placing in groups, because that how we are being giving that a common names to that, to the data, and to like it is our beneficial, like we are able to see the different items at the particular stage of in group data. Okay, collecting A also, B also, C, D, E, and we're collaborating, giving a cluster a name of EFG. Okay, that is what the group data is all about. Like we are placing that data in a group where everything is common to that. Like suppose A and B is the length data. Okay, B and C is the group data, is the structured data. Then then E and F are the it's advantage data. Okay, so all the three of the data is been clustered in the single part that is named as the D data. Okay, that how it is similar to you, because all the data has been presented as a single place. Now further moving to the calculations. Now what is the calculation data? Now when we use a numerical value, or when we use a like perform the calculations to get that data, okay, we always use some of the calculators, we always use some of the external devices, but we also have the electronic spreadsheets. Okay, the electronic in laptops also you have calculators, in mobile phones also you have a calculator. Every complex calculation are being performed by a similar calculator, a simplest calculator. Okay, that is what the data is being performed as in structured part. For seeing that output, suppose you don't have the calculator and you want to see that output, you have a lot of things to do with the like statistics and everything. Like graphs are being there, then charts are there, histograms are there, bar graph are there, then heat maps are there. Okay, a lot of things is there to check your display of data. Now, after like when your computer process your data and it needs to be shifted or it needs to be visualized. So what happens when you use your data as a visualizing part? Your visualized and the processed data is always and always accurate, as well as that data is faster than your raw data. Okay, so like suppose you are being using the preprocessor, any other preprocessor or anything, or like storing anything. Suppose I am using memory card, hard disk, pen drive to store my data. Each of the hard drive has an each of the memory storage has an his like its own specification. I don't know, like it's my pen drive, it's 32 GB, like any 8 GB, 16 GB, any of that. I don't know. Okay, so each of the allocation, each of the like memory allocations have an it's more of specification to do that. Okay, now what are the advantages of computerized system? For using the computerized system, if now everything is in digital. Okay, so we cannot say like it's not digital, or we cannot like suppose we are being work from home is there for every companies. Okay, for every of the startups. So it's obviously we are not going to there. Okay, if we need to print out some of the pages from a printer, and we already have the printer, we are not going outside to print that page from the cafes or anything. We know how to print it. So everything is being modernized in this modern era. Okay, and the computerizing world is also bringing a lot of uh, like more of technology that is also helping us to be advanced in structure. Okay, being an like computerized system has an advantage. It has speed, more of the speed, more accuracy, more efficiency, more of variety, ease of use, and it has a more capacity. Okay, now what are the basic statistical method for understanding the data? What how we can use a more of the statistical method to understand the data in a further use of numpys, data processing, or any of it. So now what is statistical analysis? It is an properly an organization, and every quantitative or the qualitative data that is being procedure at an like these all are been configured out at the descriptive or inferential statics. Okay, now you are being using that data for exploring something or for collecting something or presenting the large amount of data in a single output. And how you will be doing? Obviously, you are having some of the statistic analysis in that data, and you are being presenting that. So, what are now elements of the statistical analysis? To understand basic of that statistical analysis, we always use some of the more comparison proportional, because that is more considerable nowadays, because interpretation of the data or interpretation of the result both are being guiding to the clinical or the biological considerations. Okay, these are not nowadays, there is not a time, each and everyone is such a busy, like they are being considering like before getting the each and every output, we should get a single output of our data. Okay, so for collecting that mean, median, then its mode, then standard deviation and its formula, and how we can do as in both of the statistical analysis for collecting the mean. So what mean it is mean, like mean as being introduced as the average of all the numbers in your collection to defining the basic output. Okay, for calculating the mean, we always use a formula sum of all the values to number of values it has. Okay, suppose I have 10 values, I'm ranging to five five numbers. Okay, I am just ranging to five numbers. So what is like I'll be doing the sum of data. So my sum of all the values will be 1 plus 2 plus 3 plus 4 plus 5, and the number of data values are there is 5 data values. Okay, that is how the mean has been calculated. So symbolically we can use as the x bar sigma of x and then n to the power. Okay, now what is x bar? It means that it will read the bar with the set of all the x values it has. Okay, now sigma x means like it is the sum of all the x values containing in the data. Okay, and then n is the number of the number of x values in that. Okay, sigma x, that is the sum, and the proper n means the number of values in the x value. Now, what is a median? Okay, calculating the median, we always observe that it has been arranged in such a structure that we can use an ascending or we can use as a descending part, but depends upon how we can order that magnitude. Okay, magnitude, depending on the magnitude, that is very important, because we don't know it's an like even or it's an odd. Okay, if it's even and odd, it particularly depends upon the situation. Okay, now how we add or how we like consider that numbers in ascending order or descending order, depending upon the magnitudes of it. Okay, now when we give a raw data to any of the processor, it always observes, like if we have the n total number of observation, if it has a value of that median is that n plus 1 divided by 2, so the nth term will be called as a median. Okay, when we have the even number, suppose we have 6 values, when we have the even value, that the mean is the actually calculated as the n by 2. Okay, but when we having that odd value or anything, that is to be considered at the plus 1. Okay, and that is being given to the nth term in that will be the median. Suppose we have a median of the data that is 10, 20, 30, that the median of this actually number will be 20th. Okay, according to the formula given above. Now, what is mode? We read about the mean, we read upon the mode, mean, median. Now we will be reading about what is mode in that. Okay. So now mode is a value of series which appears most frequently than any of other. Like suppose mean were the sum of all the values and the sum of all the number of values, to the number of values. and median are the observation that are arranged in ascending or descending order depending upon the magnitude. And then now mod is like we have to get the series value of series which will be frequently which will be frequently being given to any of our other group data. Now for the group data we use the mode formula, that is m naught is equals to l naught plus delta 1 divided by delta 1 plus delta 2. Okay, now what is L naught? So L naught is a lower limit of the model class. C is a class interval. Delta 1 is a difference between model frequency, the preceding class, preceding like what classes we have in further or like in a descending or ascending order. Delta 2 is the mode of delta 2 is the model difference between the frequency and the following class. Okay, now it is not considerable and it is not predefined. Actually they are, but they are not in a state of manner where we frequently arrange the series of the value of series. Okay, now we don't know what was the limit of the model class, what is the preceding class, what is the following class. It all depends upon like how the class is being. Suppose it's a negative part, so the situation will be like according to that. What is standard deviation? Most important point in the NumPy, then machine learning, Matplotlib, and everything, because pandas also use this all the standard deviations part in that. So what is the standard deviation? It is always and always being defined as a positive square root of arithmetic mean that sum of like all the values to the sum, the number of values. Okay, arithmetic mean of a square of a deviation of given observation from their arithmetic mean. Okay, just try to understand that. We have a formula for that in upcoming slides, the next slide. So always remember that the standard deviation is defined as the positive square, that is positive square root of arithmetic mean of a square of the deviations of given observations from their arithmetic. See what is being linked to that. Okay, standard deviation is linked to from the positive square root to the arithmetic mean. Okay, the standard deviation is being denoted by the sign side. Okay, now when the standard deviation is being done, it is always been given as this formula. This is for the sample and this is for the population we calculate. Okay, when we are being calculating the populations or any of the programs of that or the problem statements of that, we use this of the formula, but the sample formula is this. Okay, basic necessity of the formula is this. Now what happens if when we use a normal distribution curve or where the mean, medium or interval range or the standard deviation, these all are been given to the median first of all, and after that the value is being depending upon what value is being. Now this is the value, just remember that this is nothing, this is a point given as a median and these are the square in that. Okay, just remember that this is the square. Now the median has been calculated up to Q1 and Q3. What happens when a value has been increased to the graph? It will be like reverting back first of all up to -3 sign, and it will be giving to us to the positive with the most positive part. Okay, the standard deviation is an intergradile range also. Now what happened when it is being surrounded by the most of the, like there is a disturbance noise. Okay, suppose there is a disturbance noise and you are not able to get that proper decibels in your graph. Now when you use filter, okay, now using your filter, it always been given to the standarding of filter part is been given to the bulging up. Okay, now so there is a positive, there is a negative deviation. Okay, now positive and negative deviation depends upon how the part is being extended by the program written in the course. Okay, it has been written by the deviation formula. Okay, there how the program is being run upon and the graph is made. Now, what are the data analysis? Now, moving forward to the what are the data analysis and what how data is being inspect or anything. Okay, Data analysis, obviously, analysis means we are like uh, judging out the data. Okay, we can call this analysis of data or data analytics. Okay, any of that. Now, what is the purpose of doing the data analysis and how we can do that? What is the process of data analysis? For doing that, always remember the 4 steps, because when you are being performing any of your projects or anything, you will be doing only 4 steps of the for the data analysis. Okay, not for anything. Now, for that, it is inspecting, it is cleansing, it's transforming, modeling data. Now, modeling data, that doesn't mean like you are like performing any data and performing any data to subsequent manner. No, you are being performing the modeling your data to get the useful information, to get that all the useful suggestions or all the useful supportive decision making, because it how you will be getting more often to that. Now, what are the Python packages? Now, how the Python packages are being done for the data analysis? So there are 5 of the Python packages. There are many more, but what are being judged out in your data analysis that are being given to NumPy, SkyPy. That is the fundamental scientific computing. Then it is the pandas. So pandas is for data manipulation or analysis. Matplotlib, it is only for visualization and plotting. Okay. Then scikit-learn and your stats model. Okay. Scikit-learn, that is for machine learning and data mining, and stats model, that is for the statistical modeling or the testing or your analysis part. Okay. Now, when we are being using the NumPy or any of that, you are always being using with the modeling, your with data mining, with data manipulation, or that is for the plotting. Because if you don't need the output just to remember, to visualize just handwritten or the computer written words, you don't need it. You need more effective output. So you are being using the matplotlib for that. Okay, for using the matplotlib, it is always and always giving the beneficial to you. Got my point? Now, moving forward to what NumPy is and how NumPy is being performed. So, NumPy is a great package that is meant to be numeric. NumPy, the definition of the full abbreviation of the NumPy is numeric Python. And that is a great package which is required for high performance computing in data analysis, because NumPy is such a thing that is a lucky charm to your programs, okay, or your Python. It is just a very beneficial and very important to know at. And whatever programs you are being writing or how you are being writing that, it depends upon you. Okay. Now, if you are being using low level library, that is the C or the Fortran, that is the mathematical. When you are being using the mathematical functions, that is used for the high level. Okay, now when you're being using the for the high level or the intending power, that is always and always allowing you to overcome the problems while your program is slowest or your algorithm is slowest or the Python is being you're being performing, that is slowest. Okay, these all are being done with the multidimensional arrays or the function that operates the array. Okay, now there are like 3 types of arrays, that is 1D, 2D, then multidimensional, or 3D, 4 types. Okay, so all are being like when you are being performing that, all are being given to the structure to you. Okay, but when we import, this is the way we import our NumPy. Okay, like any of the package we want to import, I just we write to import the package name, that is NumPy, and just click enter to that. Now, how the replacement, how NumPy data replacement for Matlab. So, when Python was introduced by Gerda van Sam, he just declared the characters in your Python. Okay, he just performed like which character is suitable for writing. He just printed his own name for the Python. but standardizedly he thought like it is mathematical expressions now coming upon, and I can perform that as in software, or we can get it as an editor. Moving forward, he just presented in the lab and it got finalized. Then he just declared as many of the packages he can in the second and first version. Okay. Now we people are also using the packages even in our third version. So how it he like how NumPy is a replacement for Matlab. So NumPy, like Python, is a combination of NumPy, SkyPy, and Matplot. So these all are being used to replace the MATLAB. MATLAB, we used to get that as a like matplotlib module always been provided by the MATLAB only. Like it just has a similar function. It has a just similar function of plotting functionalities or like pin out functionalities. Then it's end out, and there are the scale functionalities. Okay, these all are being same just like the matplotlib, but the functionality in Matplotlib is much more higher than MATLAB. Okay, the functionality, the basic functionality is just the same. We don't say like it is not. But what happened, like it is a combination, like in Python we have a combination, such a big combination of NumPy, SkyPy, or Matplotlib. These all are being using as a huge replacement. Just you can see in this block, in the Python there are more of the packages being done there. Just try to understand that in this block NumPy is there. Under this block only we have a SkyPy. Okay, now in a matplotlib we have its own functionality as well as a SkyPy and NumPy. Okay, now each of is there as a subset and the preset of them. So matplotlib is just in for plotting, and the Python has a huge of the packages to replace the MATLAB. Now what happens when we use an extension for C, or we use an array oriented computing? What is the benefit of that? So for the benefit of that, it is efficient, that has more memory. In memory, that is there is contagious, that is we have a strided part or strided locations. And homogeneous, that means the types can be algebraic or any of that, but it can be homogeneous. Okay, so single element of the data type, that is the type, we can progress at the 0, 1, like up to like single digit. So it is not being configured out if we have to use a double or anything. We can use it when we perform some of the programs. So I'll make you understand here. So NumPy has a great applications and has a great output application, that is it can use for the image processing, signal processing, linear algebra, the like it can be used for the statistical algebra, then it can be used for the multiple algebras and the capturing parts. Okay, so just a line is there that NumPy is a foundation of the Python scientific stacks. Okay, NumPy is just a foundation, and there are more of the packages that are pillars to your Python. Okay, so now what are the NumPy ecosystem? Ecosystem for the NumPy, that what surrounding NumPy has, how NumPy has been executed with us more often more of the functionalities. We have OpenCV, then PySal, Numerix, then Stropy, PyTable, Stats Model, PyPython, SkitImage, SkitLearn, Numba, then SkyPy, Pandas, Matplotlib, and NumPy. These all are the ecosystem of the NumPy. Okay, whatever we will be using or anything, these all are the preset of the our ecosystem. Now, how we use an operations, how we use to configure the operations of NumPy. Okay, now just remember these all the points, because these are all the points which gonna help you about like making any of your projects, or making any of your research papers or anything, because operation, using the operation, these are the foundation of your like NumPy, how we can make an operations for using NumPy. First thing to remember that it has the fast victorious array operations that is used for data munging, cleaning, subsetting, filtering. Then it is transformations or any of the kind of computations of that. Okay, like we want everything fast victorious array operations and that. Now second point, moving to that, it's the common array algorithm. We use assertion sort, we use a bubble sort, simple sorting, line sort, then alphabet sort, then it is the stack sort, queue sort. Okay, so DQs, everything common array algorithm is being used in this. That is the unique, and obviously that is being more usable to that. Moving forward, that the third point, that is efficient descriptive statics, that is meant for the aggregating or summarizing data. When data is being aligned or data is being relational to more of the manipulation, just for merging or joining together any of the heterogeneous data sets, these all are being given to the NumPy. Okay, these all are the operation used in that. Nothing else, because in further we learned about that we have to clean the data, we have to model that data. Okay, these all are the alignment we can give to our data to manipulate for the further relations in that, for merging, for joining together every heterogeneous data sets. Okay. Now, when we use the expressing the conditional logics, means like we are using some of the logics to get that arrays. We want like whether it should be tree, whether it consists in the some of the loops, conditional statements are there, any of the operators are being used in that, any of the branches, that is if else if, then it is like for, if else elif, then the further we can use while loop. Okay, so every of the conditional logic that depends upon the conditional loops. Okay, now, what happens if we use group-wise data manipulation? It is easier for us for the transform the data, aggregate the data, and for the functioning of the data. Now, what is the core Python and what is the NumPy in that? In core Python, that only means Python with not having any of the specifications in the module, because when we are using the core Python, we don't have the NumPy in that. Okay, so advantages of using the core Python is, it first of all, it is a high level number object. Second consists of that it has containers. In high level number, it contains integer, floating number. In container, it has the list, insertion, how to append it, how to delete it, then how to sort that list, then remove that list, how to add the elements in dictionaries. There are many more because we read yesterday about the data types in Python. So containers all are been creating in that. So advantages of using the NumPy, and what are the advantages using NumPy with Python? Okay, not except Python as in core Python. So array oriented computing, all the array that are being oriented with the proper sequence. Okay, that are used in NumPy, and that is efficient to use and efficient to implement also in multi-dimensional array. Multi-dimensional array, that is 1D, 2D, 3D, and we can add upon more of it. Okay, now you want only just for the 1D or 2D, but you don't have any opportunity to get the multi-dimensional. So you are being getting that multi-dimensional and the sequencing part. Okay, now what happened when you are being using a NumPy error? NumPy error, when you use that, it always mean like you are being using any arbitrary structure or any arbitrary sequence that are being specified the data type. Okay, every NumPy error has a space of arbitrary structure that is processed to use any data type in that. Okay, but now the array has its specific fixed memory allocation. Okay, we know using more of the list in that, we don't have any of the nature in that. But in the NumPy error or the simple C errors or Java errors, we have that memory allocation. For memory allocation, we are being structured in that. Okay. Now every dimension is being assessed, or every dimension is being given to the particularly in array or anything. We have a fixed number of byte. That means like we have a fixed number of byte with a proper elevations. Okay, so proper elevations means like we are not structuring that array, or we are not structuring that proper array points or array elements to have a striding property. Okay, so every dimension is being configured to the stepping a fixed number of bytes. That is mean, sorry, every memory. If your memory is being like, if your memory is being very much contiguous or contagious, that will automatically give you an error if you exceed the memory locations. Okay, or if we exceed the memory where the memory is to be stored, where the array is to be stored. Okay, then arrays always and always index start from 0. Okay, as we learned prior also, indexing are always being started in 0, and whatever the dimension it has, it all known as the axis of array. Now, what is the array shapes? Now, how the array shapes have been configured? One dimensional array shapes has a one tuple, that is, and tuple, yesterday we learned about the tuples. We can use the parenthesis or we cannot use the parenthesis, that's up to you. But after writing each and every element, you have to use a colon in that, a comma in that. Okay, that's how the tuple is being recognized. Now this is the 0, 1, 2, 3, 4, 5, 6, 7, 8. Now the shape of this array is 9. 9 were configured 0 to 8, but it is tuple because this comma is there for the tuple. Now what is two-dimensional array type? So two-dimensional, we always have row and the column in that. Okay, configuring, because we read about the matrices. Matrices, determinants and matrices, So it is a two-dimensional array having the two tuples in that. Now these are the rows and the columns. Okay, we have the 3 rows and columns we have 5. Okay, each of the column has been configured out and it's a tuple. The shape of this column is 3 comma 5 as a tuple. Now what is problem definition in NumPy? How a problem is being set in NumPy? Okay, a problem to be set in a NumPy. Suppose any of your question, how to understand a huge data set. We have, like, we know the data set of the lowest standard or anything, or the lowest subset. Now what if we have a huge data set? So what is the, like, solution for that? We're getting to the solution. We always, like, everyone suggests, like, it has an advantage of human perpetual system, then to convert that information into graphical representation by Matlab or any of that, because graphical, we all are being able to understand it. Okay, and it is easier to understand before, like, reading each and every output of your data. It will take a huge time of that. But what is the issue we've, like, found? How we convert the abstract information into graphical forms? Okay, we have a proper visualization of a better jobs, or proper visualization of the methods in that. Now, or here's an like, when we used to have a huge data set, we have a few of the data visualization, then it is data infographic. Now when you have a huge data, you have to read about the what are the data visualization, how we can get that a easier part. Okay, for that, the primary goal to learn the data visualization is to communicate information. Like, you can communicate your information to your output, your input. Okay, and it is always and always, I'll suggest you also for your future, whenever you make a project, or whenever you test your programs or anything, try to get the output as a statistical form. Okay, with a graphical form, whether you can go to plots, Whether you can go to tables, pie charts, graphicals, or any of the statistical graphical, any of that, because it is more often effective visualization. Okay, that is more help, that will help you to use this effective visualization to analysis. Okay, when you are been getting any of the errors in the future also in your program, your pictorial representation and the graphical representation, you would be learning more oftenly easily. Okay, because that is how you have been learning it. And it always helps you to convert your, or to have your complex data to have a more accessibility, understandable and usable code, because you are being reading that code, you are being making that code all from the scratch. Okay, or copied also, I don't know. But when you do that, when your data has been more oftenly accessible or more oftenly understandable, that is more oftenly get to more of your program in your future generation. Okay, a future generation is the whenever the any one of your program is being used by any of you. Okay, so what is data infographic? Data infographic are just a design or just in text, numbers or metaphors or any of the data type that is more often used to create your simplest data, to explain your data in more oftenly in an infographic manner. Okay, now what is the like you use the design or you use your rules to get that display text or numbers or metaphors, all are being included in the less to less interactive numbers. Okay, you have a lot of design works has been done with the displaying information, but it is more oftenly used in infographic. Now what is the comparison? So when we used to do the comparison or anything with your data, it always give you the data as in more graphically. Okay, now data visualization and infographic, now we generalize the comparison depending upon a method of generation. Data visualization, we have more numbers to use. Okay, in infographic we only have the original image created. Depending now next for the quantity and the quality of the data. For quantity of data, in data visualization we have more data. In infographic we have less data. Okay, now in the degree of aesthetic treatment we have less artful and more focused on your information itself. In infographic we are more artful, means like your data is more like in the easiest manner, I will say your data is more prettier than your infographics. Okay, and then your visualization. Infographic is more artful than that. Now the interactive versus status. Interactive means like the data changes, and in infographic it is static. It is not dynamic. Dynamic and interactive it is dynamic data. Okay, depending upon the dynamic data, it always configured like your data is either your data is being processed or not. Okay, now, what is the data visualization and how your content has been created and how you are being putting the data in a proper instance? Okay, so using graph, diagram, timeline, then template, flowchart, metaphor, mind maps. These all the data visualization we're gonna study it. And for the graphs, we always need the two axes, that is x and y axis. Okay, and x and y axis, that is more depictability data to visualize it. In the diagrams, it's just to show that something works or not. The timeline, that the data will chronologically depict the graph into something happen or not. Flowchart, metaphor, and everything is being just a visualization of your data. Now, what are built-in data type and built-in data type or hierarchy in your NumPy? These all are being just like your data types in your Python, or list, string, and tuples. These all are just like the NumPy build type. Okay, in the like NumPy, we have more classifications. Okay, we have generic. Under generic, we have four classifications, that is Boolean, object, number, and flexible. Okay, under number, we have further two classification, that is integer and inapt. Okay, under flexible, we have character, and the character and void both are being classified in string and Unicode. And integer, we have signed integer, unsigned integer, floating, and it is complex floating and double floating. Okay, in that further the classification is your byte, your short, int, long, and in your like floating it's a double float, single float, or in your unassigned data, that's u bytes, u short, or any of it, because that is just an like your classification. Nothing is being like just like your list in Python, you used to get that list as in proper type of. So that how in the NumPy you have the data time in that, because it's a NumPy is being added to the new edition of your 1.7 part. Now what happened, how many like built-in function we have or unfunctions we have. For comparison, we have the operators, just like the operators we read in the Python in your very first part. So arithmetic, exponential, trigonometric, hyperbolic, bitwise operations, logical operations, paradox, and other. Okay. In comparison, we have less than is equals to, and is equals to, and is greater than, not, and in any of that. Arithmetic, we have the addition, subtraction, it's asterisk sign for the multiply, then division, reciprocal, and the square. Exponential, we always use the log functions and that. Okay. In trigonometry, we have the cos function, sine, tan, sine cos, tan, sine tan inverse, then sine inverse, cos inverse, any of that. The hyperbolic, we have sine, cosine, tan, and the sine inverse. Okay. And bitwise operator, that is the left shift, right shift, and not and any of it. Now, what is the mind map? We read about the classification of the statistical analysis of our data, how we can do that. For the mind map, we always used to get that image to visualize all the information in the organized manner. Okay, so just like to create a single concept of the mind app, you have to just draw as an image in the center of the blank landscape page, and after that you have to associate that value. Okay, so majorly these all are having the branches. Suppose you have a mean of your like, if you have a startup and you have spread that all the startup in the different world, different countries in the world, or the different states in your country. Okay, these how these are being given as in proper branches of it. Now, how we can do the chart types, or what are the types of the chart types? There are bar, there is bench, line, pie, donuts, then combo. It's all the representation of how the chart types are being done upon. Okay. Then there's scatter, bullets, sparkline, stock, radar, bubble gauge. Then it's linear gauge, quarter gauge, half gauge, full gauge. These all depends like which matplotlib libraries you are being using. Now, how we used to like select the chart type. Okay, for selecting the chart type, what we do, uh, we have line graph, we have pie graph, we have bar graph in that. For the line graph, just that is to track the changes over the short or the long period of time. Okay, and line graph are just only and only for best for the smaller changes, not more than that. If there is a bigger change, it will not execute it. So line graphs can also be compared with the changing the same time. Now pie graph is just a circle that is defining about the comparing the parts of the whole, like 5-10% of the circle of it, and it will be comparing that. Okay, the paragraph, it is the comparing of the track, or it is the comparing changing of track, and after that it has a greater time or a change over time in that as compared to the other two, line graph or pie graph. And area graph is just similar to the line graph, what the line graph is and how it is being done. And because it has a good for the small changes it is good, but for the large changes it is not. It will take the time, it will take the time for the execution and everything. XY plot, that is just in 1D plot questions, that just to determine that relationship between two different things. One is dependent and another one is independent. Okay, either X will be the variable or Y will be the unicode of that, or while is being used for the measuring the other one. I told you either one is being like independent, or other one is being dependent part. Now, how histogram is being done? For doing the histogram, there's a graphical representation of histogram done by the distributing the more of the numerical data, or divides the value between each of the bar plotted, or each of the object being plotted in that. Okay, the shape of the histogram always and always depends upon the number of bins we provided, or the number of bins we have calculated. Okay, it is always been continuous to the quantitative variable, because it has to divide the values into the bins, and will show the number of objects in that. Now here is in 2D histogram, how the 2D histograms are being done. It is always being shown to the joint distribution of the value of the two attributes been given as, and the two attributes are dependent, or it depends upon the what is the condition been provided to that. Now, what is box plot? Box plot, it is the for the all these plots or everything. These are all for the showing the data. Okay, and for displaying the distribution of the data, we use a box plot to compare the attributes of it. Now, what is scatter plot? This is the most important plotations of all the all the programs we will be performing, or you will be performing in your future. This is most important to that. In the 2D, we have the 3D scatter plot also, but that is depending upon the which additional attributes you have to add, whether it's a size, shape, color, any of it. Okay, that will summarize what the relationship is being there with the array of the scatter plot. Here, the scatter plot of the array's attributes are being resembled. The counter plot, this is all depending upon 3D surface, 2D surface. In 3D surface, we will be having the z axis, and that z axis are being constantly be changing. That is not the counters, and the partition of plane is just similar to the similar values we are being inputting, or any of that. And these all are being like displayed on temperature, rainfall, air pressure, and more oftenly the more of the elevations part. I hope it's clear to you. Everything is being clear to you. Any doubt to anyone?
Let's quickly take a pause and see whether anybody has any doubts.
Yeah, sure.
I don't see any doubts coming by. Okay, probably what we'll do, we'll try to wrap it up for the day here, and let's continue the next part. I think the next part would be structured data, is it? Okay.
Yeah.
Okay, so we'll continue the structured data and all the other parts from tomorrow. If you guys have any queries or anything, please do not feel hesitate to reach out to us. You can just drop an email, or you can even WhatsApp. Okay, thank you very much, Anshika. Thank you guys for attending this session. Have a good day.
Thank you, everyone.
Thank you.